This brief video looks at solving a nonlinear programming problem. Now the big difference here is that we have nonlinear equations within our problem, but the setup is essentially the same. This problem is discussed in the slides, but this is going to show you how the actual solution occurs. So what we have here is, if you recall, we have a lost vehicle, and that vehicle is some estimated distance away from 3 cell phone towers. Over here I have in my spreadsheet the position of the towers, towers 1, 2, and 3, and then I have the estimated distances based on the cell phone signal. Okay? Here we're going to have the location of the car. Now see, if I change these, you'll notice a little graphic over to the side is changing. So right now the car is at 1, 5. If I change the car to 10, 5, then the car moves. Okay? So the values in yellow are what I'm going to be determining. I want to find where the car is at. Over here I have some calculations involved. First I'm going to calculate the distance. The distance equation is discussed in your text, but the distance between 2 points is the difference in the y values squared minus the distance in the x values squared. Add those together and then take a square root. That will give you the distance between 2 points. So in this particular cell that I have highlighted here, I'm calculating the distance between my guess value of the car and tower 1. This would be between the car and tower 2. This would be between the car and tower 3. Okay. Now, I know what I believe the distance is from the real car and those towers based on the cell phone signals. This is the distance between my guess at where the car is and the cell phone towers. So I'm going to take the difference between those two. So you'll notice I get a difference, but you'll notice some of those differences are negative. They could be negative, they could be positive. This leads to a problem because if we simply add them together, negatives and positives can cancel out. So I'm going to square each difference so that I have the difference squared here, and then I'm going to sum that up. So if I guess the correct value for the car, this should go approximately to 0 because the distance between where I'm guessing the car is and where the car actually is would be very small. So I'm wanting that orange value to become very small. We're now going to activate the solver. I already have things keyed in to keep the video short, but you notice I-12 is what we're trying to minimize this time, not maximize. We're minimizing that difference squared sum by changing the location of the car. Okay, that's C12 and D12. And my only constraint this time is I'm going to say that C12 and D12 must be greater than or equal to 0 because I know that the car is not way off in the negative areas. So it just limits how much I have to search. This time I don't need to make unconstrained variables non-negative because I've already added a constraint that says that. Okay, I could have clicked this button and not done that constraint, would have been fine. And this time I am not going to do the simplex. I'm going to do GRG, that stands for Generalized Reduced Gradient Nonlinear Solver. If I do linear, it won't work. And we should be able to solve. Sure enough, we get a solution. Everything is converged, so let's keep it. And we find that the car is at 8.04 in the x direction, 6.05 in the y direction. And you'll see that the total difference between the distance based on my guess value and distance based on the cell phone signal is almost 0, 0.07. So everything's looking fine. Main thing to take away from this is that solving linear and nonlinear problems is really not that different within Excel. What's different is how hard they can be for the computer to handle. Nonlinear problems are more challenging and sometimes the computer may not be able to find a solution.